circle. Reducing can be a 90 degrees or a different measure of angle in our circle. So if a tangent and a chord intersect at a point on a circle, then the measures of each angle formed is 1/2 the measure of its intercepted arc. So the first theorem that we have, it's about the tangent line and the chord segment or the chord line that we have in our circle, wherein the tangent and the chord intersect at exactly one point in the circle. And to find the measurement of that circle or the measurement of that angle that is being made by the tangent line and the chord line, you're just going to get the half of the measurement of the intercepted arc. When we say intercepted arc, you can use either the minor arc or the major arc being made by the angle. The intercepted arc, for example, if the measurement given is the arc BA or AB, so you're going to use this arc. Or if the given is the measurement of the arc BCA, you can use that one. Either of the two intercepted arc in the angle with its, which is made by the tangent and our chord. You're just going to get the half of the measurement of that intercepted arc. Or dividing to the measurement of the intercepted arc that we have. For example, we have this circle. For example, we're going to find the measurement of angle 1 that is being produced by our tangent line BM and the chord AB. As you can see here in the circle, the given measurement of the intercepted arc BA is equal to 130. So the given arc is this one. So since that is the given arc, so we're going to use the measurement of that arc. So the measurement of angle 1 is equal to half the measurement of our arc AB. So if arc AB has a measure of 130 divided by 2, so that means the measurement of our angle 1 in the circle that we have is equal to 65 degrees. So that's how we get the measurement of the angle that is being produced by a tangent line and a chord intersecting at exactly one point. But if we're using or we're looking for the measurement of the arc, and if the angle is given, as you can see here in the circle B that we have, the measurement of angle L is equal to 125. So to find the measurement of arc KJL is equal to twice the measurement of the angle. So when we are looking for the measurement of the arc, given that the measurement of the angle that is being produced by our tangent and chord is given, we're just going to multiply it by 2 or twice the measurement of the given angle that we have in our circle. So measurement of our arc KJL is equal to 2 times 125, which is equal to 250. So that's the measurement of our arc MKJL. So that's how we use the first theorem in finding the angle of our circle. So you need to check first if the angle is being produced by a tangent line and a chord. So let's have another example. Applying the first theorem about angles that we have. Can I clear the screen with this example? So for example, we have this following circle. We need to find the measurement of angle 1. As you can see, angle 1 is being made by our tangent line and a chord. So that means we're just going to get the half of the measurement of our arc that measures 210. So what is the measurement of angle 1? Angle 1 measures half of 210, 105. So that is the measurement of our angle 1. So in our second circle, what we're looking for is the measurement of the arc. The angle is given. We need to find the measurement of the arc, RST. So what is the measurement of the arc RST that we have in our circle? If the measurement of the angle is equal to 98 degrees. Times 2. If we're looking for the arc, we're just going to multiply it by 2. 196. So the same with the circle 3 number that we have, the measurement of the arc xy is equal to 80 times 2, 160. So that's how we find the measurement of the arc and the measurement of the angle that is being made by our tangent and a chord. So if you're looking for the arc, you're just going to multiply it by 2. If you're looking for the angle, you're just going to divide it by 2. Okay, that is for our first theorem. An angle made by a tangent and a chord. Okay na? Question about the first theorem that we have. Okay na tayo with the first theorem. Let's proceed with our second theorem and finding the measurement of our angle. The second theorem that we have is an angle inside of the circle. This angle is being made by the two chords intersecting at one point. So if two chords intersect inside a circle, then the measures of each angle is 1/2 the sum of the measurement of the arcs intersected by the angle and its vertical angles. So that means to find the measurement of the angle, what you need to do is to get the half the sum of the intercepted arc. So for example, we're going to find the measurement of angle x. So the formula in finding the measurement of angle x is 1/2 the sum of the two intercepted arc. The two intercepted arc is angle BC, and the vertical arc, which is arc DA. So measurement of arc BC plus the measurement of arc DA. That is what we're going to use to find the measurement of our angle X. But if we're looking, for example, let's say this is angle Y, we will be having the measurement of angle Y is equal to 1/2 the sum of the intercepted arc. The intercepted arc of angle Y is arc AC and arc DB. So measurement of arc AC plus the measurement of arc DB. So that is what we're going to use. As you can see, the intercepted arc are the vertical arc that we have in the angle. The one at the front of the angle, the arc that is front of the angle, and the arc at the back of the angle. That is what you're going to use to find the measurement of the angle. Yung arc na nasa unahan ng angle at yung arc na nasa likod ng angle. That is what you're going to use in finding the measurement of our angle inside of the circle. Okay, let's have an example. Okay na with this one, can I clear the screen? For example, we have this circle. For example, we're going to find the measurement of our angle X. So since we're looking for angle X, we're going to use the intercepted arc, yung arc na nasa unahan niya, which is arc KL, at the arc at the back of the angle X, which is arc JM. So measurement of angle X is equal to 1/2 the sum of the measurement of arc KL plus the measurement of arc JM. So 1/2 measurement of arc KL is equal to 156 plus the measurement of arc JM is equal to 130. So 156 plus 130 is equal to 286 divided by 2, which is equal to 143. So that is the measurement of our angle X. So let's say we're going to use the same circle. For example, we're going to use the same circle, but for now, we're going to find the measurement of angle Y. Let's say that the measurement of the two arcs that is intercepted with our angle Y is equal to 30, and another arc is measured 50. So given that the measurement of the arc ML and JK is present in the circle, so we're just going to find measurement of angle Y is equal to measurement of the arc ML plus the measurement of arc JK divided by 2. Or it's the same as 1/2 times the sum of the two intercepted arcs. So measurement of arc ML is equal to 30 plus the measurement of arc JK is equal to 50 divided by 2. So we have 80 divided by 2. So the measurement of our angle Y is equal to 40. So that's how we find the measurement of the angle inside of our circle. An angle that is being made by the two chords intersecting at one point. Okay, question in this second theorem that we have in the circle. What if magkatabi? Sige, let's have an example for that. Can I clear the screen with this one? Sige, let's draw a circle. Magkatabi yung angle? Is that what you're asking, Chloe? Hindi siya vertical. For example, this is angle X and then angle Y. Is that what you mean? Nagkatabi si X at saka si Y in finding the angle? See, A, B, C, and D. We have the same theorem pa rin. We're going to use the same theorem to find the measurement of our angle X and angle Y. But if the chord, you can apply the other theorem when it comes to circle if the chord is in the diameter. For example, this is the circle. The chord that you have is diameter. So if you have a chord which is diameter, that means you don't need to solve for the measurement of the angle. It's already equal to 90 degrees. Each angle is equal to 90 degrees. But if the chord is not the diameter of a circle, we're going to use the same theorem, wherein you're getting the half of the sum of the two intersected arcs. For example, here in the circle that we have, if we're going to solve for the measurement of angle X, what intercepted arc are we going to use? Is it arc AD or arc AC, arc BC, or arc DB? What arc are we going to use to find the measurement of our angle X? Anong measurement of arc? A, AD, AC? When you are solving for angle X, the arc that you're going to use is the arc in front of that angle and the arc at the back of that angle. Ano ang arc which is at the front of the angle X?
40.
40. Si 40 ang nasa unahan ni angle X. Plus the arc at the back of angle X, which measures, ano ang arc na nasa likod ni X?
50.
50. So 40 plus 50 equals to 90 divided by 2. So 90 divided by 2 is equal to 45. So 45 degrees is the measurement of our angle X. So that's how you can be able to identify which arc are you going to use. Si arc na nasa unahan ni angle and si arc na nasa likuran ni angle. Okay? And get the sum of those two intersected arcs and then divide it by 2. Okay. What about the measurement of our angle Y?
70 plus 60.
70 plus 60 divided by 2 is equal to angle Y equals to what?
65.
65 degrees. So we have 65 degrees for our angle Y. So that's how we use the second theorem, finding the measurement of the angle created by a two chord intersecting at one point. Let's have another example before we proceed with our third theorem. So let's proceed with the third theorem that we have, which is the angle outside of the circle. So this angle is being made, it can be made by a tangent and a secant, or it can be made by a two tangent or a two seconds intersecting outside a circle. Then the measure of the angle formed is 1/2 the difference of the measure of the intercepted arc. So in finding the measurement outside of the circle, the angle outside of the circle, you're going to subtract the measurement of the two intercepted arc. Intercepted arc is the one that we have here and this one. Those are the intercepted arc of the angle. Get the difference of that intercepted arc and then divide it by 2. So for example, if we're going to solve for the measurement of angle P, we have 1/2 the measurement of arc TB minus the measurement of the arc TA. It depends on the given. But if the given is the measurement of the arc A, D, B, so for example, this one, the intercepted arc is arc AB and arc AB, ADB. So those are the arc. The arc that is being made by the angle. Yung arc nakasali sa angle. Okay? Those are the intercepted arc that you're going to use in finding the angle, the measurement of the angle outside of the circle. So it can be in a form of this one. The angle is also outside of the circle. Angle E. The intercepted arc that you're going to use is arc AC and arc BD. So the arc is involved in creating the angle. That is the intercepted arc that you're going to use to find the measurement of the angle outside of the circle. For example, we have this circle. Okay na with this slide. For example, we have this angle. Find the measurement of angle X. So since we're solving for the measurement of angle X, we're going to use the intercepted arc that we have in our circle. So measurement of angle X is equal to half of the difference of the measurement of arc DB and the measurement of the arc AD. Arc BD is the arc that is near to the angle. And the other intercepted arc is the arc in front of the other arc that you use in finding the measurement of the angle. So measurement of arc DB, we have 76 minus the measurement of the arc AD, we have 178 divided by 2. Lagtarin natin so it will not become negative. We have 178 minus 76. So 178 minus 76 is equal to
51.
51. So that is the measurement of our angle X. So in finding or using the measurement of the arc, intercepted arc, the first Arc is the one outside of the circle. Yung malaking arc ang laging mauuna in solving for the measurement of the angle outside of our circle. The bigger arc will be the one that you're going to use first in solving for the measurement of our angle outside of the circle. Let's have another example using the third theorem that we have. For example, we have the circle. So for example, we have this circle. With an arc, we need to find the measurement of our angle y. With an arc measure of so we need to find the measurement of the angle y. So let's say this is measures 30 degrees and this is for example, that is the circle that we have. And we need to find the measurement of our angle y. So measurement of our angle y is equal to half of the difference of the two intercepted arc of our angle. The two intercepted arc is arc CE and arc BD. That is the two intercepted arc that we have in our circle. So measurement of arc CE minus the measurement of arc BD divided by 2. So measurement of arc CE is equal to 50 minus the measurement of the arc BD, which is equal to 30, divided by 2. So measurement of our angle y is equal to what is the measurement of our angle y? 10 degrees. So that is the measurement of our angle y. So you can see in this circle, the 2 second is the one who created an angle outside of the circle. So let's say we have this circle being made by a tangent and a secant. For example, we have the circle, we have secant AB, and we have tangent AD. And we need to find the measurement of our angle A. If arc BD is equal to 112 and arc CD is equal to 25. So what will be the measurement of our angle A? So using arc BD minus arc CD, that will be the measurement of our angle A. So measurement of angle A is equal to the difference, half of the difference of arc BD and arc CD. So arc BD is equal to 112 minus our arc CD, which is equal to 25, divided by 2. So the measurement of our angle A is equal to 112 minus 25 divided by 2, 43.5 degrees. So that's the measurement of our angle. Question in this theorem. Okay, let's try this following circle that we have. For example, we have this circle and we need to find the value of y. When you try to find the value of y in our circle, to find it, the value of y for our circle.